I will show you how to run a convolutional neural network in Keras and use it to identify bolts and nuts in images. This is part of a course that I give on Udemy, so you can find the corresponding coupon code in the description of this video. There you will find also the corresponding code and material and pictures and everything that I used here. So pretty much the idea of convolutional neural networks is to exploit the locality of pixels. So that's the great thing. Convolutional neural networks operate with convolution filters and max pooling operators that basically grab features, or the most relevant features, from the image, apart from all the typical neural network structure that comes after that. So you can think that it's a kind of way of finding the appropriate filters that maximize the probability of correctly classifying an image. Examples of filters, well, you can think that Gaussian blur is a filter. You can think that the edge blur is a filter. So any filter that you can find, for example, in Photoshop is a valid filter. But what convolutional neural networks does is it finds the best filter that maximizes the classification, essentially. Apart from that, as I just said, it also includes many parameters for all the typical neural network architecture that comes after that. So you can think that it's pretty similar to all the parameters that you have at that point in for example, a multi-layer perception neural network. So in this example, I will use Keras plus Theano, and I will do the following. So I will use a specific class that I designed to load the images. So my images will be these ones. You can see here in train, I have bolts and nuts. So lots of them. Well, not so much, not so many of them, honestly. But anyway, we want to classify them, and this is certainly a challenge. So in order to load this, I will have a very specific class that I constructed that will pull the last ID or the last character from these images, which, as you can see, for the nuts it's a 1 and for the bolts it's a 0. So you can see the last digit here is a 0. So that it will assign that to the corresponding class, and that's perfect. And it won't use these first characters that are before the underscore. It won't use them at all. You can see that the images here, some of them are quite different. Some of them contain like a strong shadow. Some of them are rotated. Some of them have a glossy surface here or a glossy reflection. Anyway, so we have different images, and certainly will be a challenge. So my code will loop through all these elements, and it will stack them in the appropriate dimension that Theano expects for convolutional neural networks. Theano expects to have a 1, a 3, and height and width. Or you can also use 1, 3, width, height. Both of them are valid, they're basically the same. The trick is that they need to have a 1 here. So that's pretty much it. In my case, I will have lots of images and I will be stacking all of them together. So I will stack one below the other one. That's pretty much the idea. So I will return an array containing here many samples, and then here the 3 channels, and here the height and the width. So that's pretty much the idea. So let's see how we do this. Here you can see that I specify a path, and I specify a height and width, and then I call a method that I call buildML matrix, which will create a matrix which is should be here, global matrix. We will now see what's inside global matrix, and it will also create here x.labels, which will be a vector containing the labels that were extracted. So I will first remove all this and first execute this first part so we can see how X needs to look like. So I'm running Theano. This is a minor error with my horrible GPU, which is lacking one driver. So this is what's printed within my code. It's basically processing all the images in my training sample. And that's it. So let's see so this is the matrix that I need to build. It has 60 samples, so 60 images, 3 channels. Remember that we have one channel for red, one for green, and the other one for blue. Then we have 50, is it 50? Yeah, 50 columns and 65 rows. So that's pretty much it. I resized these images because this was the ratio that I had. So if you look at this image here, it's huge. So it's a 1:33 ratio. So I just decided that 50 by 65 was reasonable. We could, for example, have used 100 by 133, which would also be correct. The important thing is that we respect the same ratio. So with this, I'm standardizing all the images to a standard size, just to make sure I don't have different things there. So this is the matrix that I need, and then the labels, this will essentially be ones and zeros. So that's pretty much it. And finally, I need to execute this code here. And that's what I will do in the next part. So I'm ready. I will save the changes and I will run my code. And after I run my code on my training sample, I will do an evaluation of what's my accuracy on my testing sample. So let's now execute this and see what happens. Training process. You can see that I'm in 55% accuracy, which is quite good. Now I'm 73, so that jumped quickly. 88. 55. 78. 65. 80, 3. You can still see how the loss function is decreasing in every iteration. We started with 154 or 0.77 in the first one. Now we are practically 0.40, which is quite good. So it keeps falling, 0.32, and the accuracy is now practically 90%. So I will keep this running for 60 more epochs, but we're pretty much in a 95% accuracy, which is very, very good. So finally the training has finished. Thank God, it was taking too much. So long. So anyway, I have 80 epochs and now I have a 2% loss, well, 0.02 error loss. And then I have an accuracy of 100%, which is quite good, honestly. But obviously we are evaluating with our training sample, which at this point I'm not very sure how reliable that number is. Because remember, we always want to evaluate on our testing sample. So what I did here was to reload here a new instance of this matrix CV ML3D class with a 65 by 50 size, and I will load all the images that are here on my testing dataset. So here you can see that I have quite a few of them. So I will evaluate them pretty much the same as before. I will transform the labels to categorical, and I will score this. So score. So you can see that I have a loss function of 0.12 and an accuracy of 100% correctly classified. That's quite good. So I can certainly compare my predictions against the labels that I had. Of course, as I was saying, the accuracy is 100%. So anyway, but we can see how these numbers look like. So you can see that I'm using pred, and I am using numpy.argmax using axis is equal to 1, so pulling the maximum attribute for all the columns. And if I see what's inside predicted, I get 0, 0, 0, 0, and so on, which I can naturally compare against y. So obviously this matches because I am predicting zeros here for these ones and ones here for the second ones. So that's pretty good. One final thing. So we have trained a convolutional neural network using Keras. We have shown that this is a viable option for predicting bolts and nuts using a wooden background. So in case you want to download all these classes and all this code and all these pictures, you can check the link below where I specify the Udemy coupon for this course, where I share all this material